Okay guys, here we go. Part B is going to be a little quicker because I don't have to do a ton of examples. You have already seen them. But I do want you to see the problems you're going to try. That's problem 5 through 18. And this is page 174, 175 of the trig book. But you'll notice I wrote in for problems 13, 14, 15, 17, or sorry, just 15, 18. I sketched in this equation, let's say, instead of what they had. This equation instead of what they had. Now, here's the thing. If you look at the original equation they have this 2 on the inside. See, if you want to graph it using our method, you have to take that 2 out. You have to factor it out so you can see what the period is. And then you have to work backwards. What would I have to multiply this thing by to get this expression back? And if you wanted to get that expression back, well, you'd have to rewrite it like that. So there you go. So what I'm trying to do is give you a heads up and help you out. I am not going to write my questions like this. I'm not. I'm going to pull that number out so you can clearly see the B value I want you to use. And then you can clearly see the phase shift that I want you to apply. So like I said, we did 4 examples in the last video. So this, you can just see, this is like, let's sketch some graphs. Let's just practice. There's a couple phase shifts here, yeah. But overall, that's it. Now these last ones, 11 to 18, these are supposed to be challenging. They are. So I'm going to eliminate number 18. I'm actually going to do this one for you. And you can then work through it, follow along. But here is one thing I wanted to leave it for you guys. And let's just focus on 5 through 10 right now. So here's the answer key that comes with the book. And I want you to really look at these because problem 5, 6, 7, 8, 9, 10. Number 1, they don't draw in their guide graphs. Do you see how I personally sketched in the guide graphs there so it might help your brain out a little bit? But here's where I'm trying to help you out the most. For some reason, whoever made this answer key wanted every answer to look like you up, you down. You down, you up. But we know that when we're graphing a secant, this guy's a secant graph, that it has that look where 2 of them are on the outskirts and one guy's in the middle between the asymptotes. We have that type of look if we graph one period of the function. So whoever made up this answer key extended it on one side so it would look like a double U up, U down. So what did I do? I took my highlighter pen and I just highlighted one period. So that is one period highlighted for you. And then the same thing goes here. I took my pen and I highlighted what one period would look like for you. Why they did this, I don't know. But everybody, you know, when they're making up answer keys, sometimes they don't think of the universal truth. I don't get it. But so number 7 is actually legit how it is, so I didn't do anything. But number 8, once again, they messed it up. If they were going to graph one period start to stop, that would have been where it starts. That would have been one period. I don't know why they graphed it that way. I really don't. But the highlighted part would be the part you would want to check against. So I did leave it the way they have it here. I did. And you'll see the answers for 11 through 18. Well, 11, 12, 13, 14. There they are. Pause it. Take a picture of it if you need to. Just realize I rewrote every single problem like this so that you don't have to. I won't do that to you on the test. So like number 13, that would be written like this on the test with the 1/2 pulled out. And then I would have x minus pi over 2. Because if I were to distribute it back in, it would say that. But, let me get rid of this. Here's 15, 16, 17, 18. once again, they didn't mark every quartile. You guys should know that by now. You should know how to mark every quartile, etc. And there you go. So here we go. Number 18. I told you I was just going to knock this one out so you could, you could actually compare it. So I'm going to write it down here. Y equals, now I know it's got a vertical shift of 2, and then it's got this compression. That my amplitude is 1/4. That's barely going up, barely going down, but it's secant. Now I'd have to pull the 1/2 out. X minus 2 pi would be the rewrite, because if I were to distribute the 1/2 back in, I'd get 1/2 x, and then half times 2 pi would give me back minus pi. So this is called standard form. I am writing every single problem I give you in standard form. I'm not going to pull any weird tricks on you. I want you to be able to do this for me. I see that this is a vertical shift. I see that this graph has not been flipped. I see that it has been amplified by a fraction, which is actually going to compress this graph down. I see there is a b value of 1/2, which will stretch out the period to 4 pi, in fact. And then I see there is a phase shift. That's what I need you guys to be able to do for me. And if you can do that, then we should be able to just knock this out. So let's start with our period. And that would be 2 pi divided by b. So this is a good old-fashioned 4 pi period. So normally this thing would start at 0 and end at 4 pi. But they have a phase shift in there. So I am going to phase shift my entire graph so that it starts at 2 pi and it ends at 6 pi. But lucky for me, if I do 1/4 of 4 pi, if I take 1/4 of this thing up here, my increments are pi, so I just get to count by 1 pi, 2 pi, 3 pi. That's easy. So let's do this thing. I'm going to have to give myself a little room, though, to mark this off. So let's see. I'm going to only graph one period. And I'm going to have to go up 2 units. Oh, come on, really? Come on, technology, be my friend. There we go, thank you. Okay, so that's at 0, but my vertical move is up 2. I'm going to make my move really big. I'm going to say that's 1. I'm going to say that's 2. That's going to be my center line because I know that I'm going to go a little tiny bit above it. I'm going to go 1/4 below it, so I'm going to say that's 1 3/4. And then I'm going to go 1/4 unit above it. I'm going to say that's 2 1/4. Okay, so that I have my amplitude as compared to my center line. So I'm just trying to make this work. And I'm not going to start here. I'm not going to start, oh, I am going to start there. That's 2 pi. But I'm counting by pi's. So that's 1, 2, that's my start. Then I go 3, then I go 4, then I go 5, and then I'm going to stop at 6 pi. Remember, there's my start. There's my stop. And I counted by pi each time. So let's sketch in this guide graph. Let's get this guide graph going. My guide graph will be a cosine graph that is not flipped. So here's the line. I'm up here. This is the line right up here. But I'm not going to start on the line. No. I'm going to start above the line. Then I'm going to, above the line. Then I'm going to go back to the line. Then I'm going to go below the line. But it's very gradual because I only have an amplitude of 1/4. So I'm not going that much high above the line or below the line. And this is going to be kind of a, come on, stretched out, compressed cosine graph. How many asymptotes should I have? I should have 2. But you'll notice when I check my answer against the key, they did it a little bit weird. but here we go. One of my asymptotes is right there. One of my asymptotes is right here. And I'm going to sketch my graph in red, keep my pattern going. Where cosine's going down, I'm going up. So this guy right here, oh, that was kind of crappy, but this guy right here, this guy right here. Now, that is one period of my function. That is, my period should start at 2 pi, end at 6 pi. But what did they do in the answer key here? Look, this is where my graph starts, and you'll see my graph goes up from there. That's where my graph starts. They didn't even do it over here. They did not do what I did. They did not. I don't know why they didn't do that, but you got to kind of be a little bit detective-like on this situation here, because if you were to apply the shift, your graph should start at 2 pi and then stop at 6 pi, like ours did. So be careful when you're checking your answers. They did this really weird when it comes to secants. Cosecants, not so much, but the secants are weird. So when you're checking them, be cautious. And guess what? Maybe, just maybe, you will come into the Zoom room and ask for help. Because I'm thinking you might get stuck on these lessons. The trig gets trickier from here on out. It does. But doesn't have to be difficult. Don't make it hard on yourself. If you need extra help, come into the Zoom room. Come in for help. All right. So guys, there you go. That was my last one. I already showed you we're on page, 174, 175 of the trig book. Those are the questions, 5 through 18. I already did 18, so guess what? You are not doing 5 through 18. You are doing 5 through 17. Oh. All right. Catch you later.